Hello geographers and welcome to today's coast lesson. Today we're going to be looking at soft engineering as an alternative to hard engineering that some people find really ugly. For today's lesson, all you're going to need is a pen and paper. In a second I'm going to ask you to go and get them for me, clear away all those distractions, decide if you need to move somewhere quieter, and then we'll get started. So pen and pencil and paper, off you go. Well done. So the title today is Coastal Soft Engineering. Underline it for me and we get started. Hard engineering is just one strategy to manage our coast. Hard engineering is where you use artificial, man-made structures to defend land against natural erosion processes. Hard engineering strategies can include groins, seawalls, gabions and rock armour. You can see all four of those look very artificial. They've been made by man and they're also quite expensive. Let's have a look at the alternatives. Soft engineering. This is where we manage erosion by working with the natural processes to help restore beaches and ecosystems and reduce erosion. Can you pause the video and get that definition written down for me now? Our first soft engineering strategy is beach nourishment. You would give people nourishment by feeding them, and it's exactly the same with beaches. Beach nourishment is the addition of new material to a beach to make it wider. Beaches can lose sediment in two different ways. They can lose sediment along the coast through longshore drift, or they can lose it into the sea with destructive waves. With beach nourishment, we are replacing that lost sediment. It can be done through lorries coming and tipping sand onto the beach, or through dredging, where they scrape up sand or sediment from offshore and pump it onto the beach. This widens the beach. A wider beach will decrease wave energy. It doesn't stop coastal erosion, but it does slow the process down. Beach nourishment can be relatively cheap. It can increase tourism through those wide beaches, and tourism will tend to make more money than the management costs, so it's beneficial. It does need replenishing regularly. It doesn't stop coastal erosion, so that sediment is going to be eroded over time. Groins are often needed to work alongside beach nourishment to keep the new material in place. Beach nourishment can cost up to $500,000 per 100 metres. Reprofiling is often used alongside beach nourishment. In beach reprofiling, we redistribute sediment from the lower section of the beach to the higher section. And what that does is it increases the gradient, increases the steepness of the beach. This is cheap to do. The sediment's all there. All you need to do is you need to get the diggers and the machinery in to move that sediment around. It reduces the wave energy. So if the beach is steeper, the waves lose more energy. It's the same with you. If you were running up a hill, you would find that much harder. It saps more energy than if you were running along a flat road. It only works when wave energy is low, and it needs to be redone regularly. In some places, after every large storm, within 24 hours, they'll have the diggers out there taking the sediment from the bottom of the beach and piling it up at the top to make sure that their cliffs are protected. Dune regeneration is our third type of soft engineering. It costs between $200 to $2,000 per 100 metres. And it's action taken to build up sand dunes and increase vegetation on them. Dunes work as a natural form of coastal defence. They absorb wave energy and act as a buffer against breaking waves. As part of dune regeneration, you can plant marram grass. Marram grass covers 50% of our UK dunes. It's a really hardy plant, and it's got an extensive underground root system. And those roots over time will spread out and will anchor all that sand in place. However, Some areas receive lots of tourists, and tourists walking over the sand dunes will destroy that vegetation and the sand dune. So, to go alongside planting marram grass, they will often use fencing to keep tourists out, therefore giving the grass a chance to grow, or putting in boardwalks, which means that people are forced to walk in certain areas rather than walking wherever they wish. So, this is a really cheap strategy. It maintains coastal habitats as well. However, it takes a long time. For marram grass to fully stable and anchor those sand dunes down, it can take between 2 to 4 years. So it's not a quick fix. And it can hinder tourists. If tourists don't like being stopped from going into an area, they don't like the signage, they don't like the fences, they can decide not to go to the area. Right, we've got a photo here up in the top corner. Which type of soft engineering is this? 5 seconds, write it down. Okay, your answer in 3, 2, 1. It is reprofiling. So here we've got a digger. That digger will take the sand from the lower section of the beach and will move it to the top section to increase the gradient. Which type of soft engineering would include building boardwalks? 5 seconds. You've got it. So dune regeneration. We would build boardwalks, we would fence it off, we would plant marram grass. First task, simple one. All I would like you to do is I'd like you to match up the definitions to the type of soft engineering. Pause the video. I'll see you in a second when you're done. Let's match them up. Big tick if you got that. Beach nourishment is the addition of new material to a beach to make it wider. Big tick if you've got that. Dune regeneration is action taken to build up the dunes and increase their vegetation. And finally, that reprofiling is redistributing sediment from the lower section of the beach to the higher section. So is hard or soft engineering best? We've got 2 different options and we need to decide which one we would use and why. Soft engineering tends to be cheaper in the short term. So it's more sustainable in that we're not damaging the environment and it looks more natural. However, it does need more maintenance. So it may be cheaper, but if you're having to redo that on a regular basis, the costs are going to add up. It's not as effective at reducing erosion. It will slow it, but it doesn't stop it. We can't protect all of our coastline though. We just can't afford to do it. So we have to make decisions about where hard engineering is appropriate, where soft engineering is appropriate, and where, unfortunately, we can't protect the coast at all. Let's have a go at making that decision ourselves. So on this map extract of the south coast, we've got location A. Location A is in Bournemouth. I've got location B over at a smaller town called Barton-on-Sea. And location C, down there at the end, just off the B3058. Can you make a decision now? You've got 3 locations, you've only got a pot of X amount of money, so in which place are you going to put hard engineering? Where are you going to put soft engineering? And where are you going to decide to do nothing? 5 seconds to make your decision now. Jot them down, A, B and C. So I think you should probably have decided that A needs hard engineering. We're going to look at why in a second. B is just a smaller town, so maybe we put some soft engineering in because it's cheaper. And C, where we haven't got residential land, is probably the place that we need to do nothing. Let's zoom in at site A and have a look. We decided that we needed to use hard engineering here. And here is an OS map extract of the town. What can you see there that means that hard engineering, so sea walls, groins, rock armour, why would they be so important to put in place? 5 seconds to think about it. There are lots of blue symbols on this map. You have a museum, an information centre, a beach for kite surfing, attractions like a zip wire and aquarium. So these land uses will bring in a lot of income, so they need to be protected from coastal erosion. The brown sections of the map inside the black lines are buildings. You can see that these buildings are quite large, so that would suggest large buildings, again, that we would think have a high value. Because this is an area that is built up, it's worth the extra money to protect the coastline with hard engineering. You're going to get something down. Suggest evidence on the map that justifies the use of hard engineering at Site A. I want specifics from the map, things or words that you can see, and I would like you to give 2 bits of evidence. I would like 2 pieces of evidence from the map that says why it's worth spending all that money on hard engineering. Pause the video now, write your 2 sentences, and I'll see what you've done. Hard engineering should be used at Site A because, and you're looking for 2 of these. You could have got there are many tourist attractions such as a zip wire and an aquarium. This will bring income to the area. There is a wide sandy beach which might attract tourists, especially as you can see it's suitable for kite surfers. There are lots of large buildings close to the coast like the BIC and a museum, which would have a high value. So the bits in pink are the evidence, things you can specifically see off the map. I've given you 3 ideas, you only needed 2. Feel free to pause the video if you want another closer look. With the help of the photo and your own knowledge, explain how soft engineering can be used to protect the coastline from physical processes. There's a lot in this. So, with the help of the photo, we need 1 paragraph about what we can see. What can you see in this photo? Tell me now. It is reprofiling. You've got diggers moving the sand from the bottom of the beach to the top. And you can see where they're really angling the sediment to make that steeper gradient. So that's the photo. Then you need your own knowledge, so you need to choose a different one apart from reprofiling. Explain how soft engineering can be used to protect the coastline from physical processes. And the physical processes we'll be talking about are erosion. How do they stop erosion? Let's have a look at a model answer to help you out. The photo shows the soft engineering strategy of beach reprofiling. So your first sentence, what does the photo show? This can be used to protect the coastline from erosion, so I've said what the physical process is, as sediment is moved from the lower section of the beach to the top of the beach. Consequently, so these connectives are in pink, show that I'm developing my idea. The gradient of the beach increases, and this means wave energy is reduced, which protects the coast from erosion. So there's a model answer, okay? But I'm not being so kind as to give you an answer you can copy down straight away. I've changed the photo now, so it's your turn. Remember, I am looking for 2 soft engineering strategies, one of them from the photo. I want your explanations developed, and I would like you to name the physical process. Good luck, everyone. Pause the video now. I can't wait to see how you've done. Are you ready to check it over? The photo shows the soft engineering strategy of beach nourishment, so you get a mark for identifying that. This can be used to protect the coastline from erosion as additional sediment is added to the beach to make it wider. Second mark. This means that more wave energy is absorbed and the waves are less likely to reach the cliffs and erode them. Then you had to do one of your own knowledge. So another soft engineering strategy is dune regeneration, which can include planting marram grass. The long roots hold the sand dune together and stabilise it. Consequently, the dunes are stable enough to act as a buffer to the waves' energy, reducing coastal erosion. You didn't have to do dune regeneration, you could have done reprofiling. Another soft engineering strategy is beach reprofiling. This can be used to protect the coastline from erosion as sediment is moved from the lower section of the beach to the top of the beach. Consequently, the gradient of the beach increases, and this means wave energy is reduced, which protects the coast from erosion. How did you get on? Well, that's it for today. We've really provided nourishment for your brain about coastal soft engineering processes. I hope you think we've regenerated your thinking about coastal management. Maybe hard isn't always the right way to go. Maybe soft engineering has got its benefits. But just before you go, click onto the next page. Make sure you deposit all that amazing learning onto the quiz so I can see how you've got on today. Thanks very much for your time. Take care, and I look forward to you joining me to have a look at Lyme Regis as a case study to see what decisions they made about hard and soft engineering. Have a great day today. I can't wait to see you soon.